everyone, this is Jonathan Colfax Math. Today I'm going to go over a bearing problem in Chapter 11, kind of the applications of non-right triangles in our IB math book. I'll put the camera over my shoulder and we'll get started. So I'll just do one of these problems and hopefully that'll help out.
Measure the height. Measure the width from here to here.
Laminated overnight on a CNC cut jig. Okay, this is section 11.5 in the IB math book, number 8. Porpor flies from A to B on a bearing of 67 degrees for a distance of 80 kilometers. One thing I will say about all of these problems, I would draw them out as large as you can, even a full sheet of graph paper. So the thing about bearings is clockwise off of north, so I'm going to draw my north-south axis to start. So that's north, that's a completely vertical line. And I'm at a bearing of 67 degrees off of north for 80 kilometers. So I come down here 67 degrees, so that would be 45, say, right? So 67 is there. And that line is 80 kilometers long and is 67 degrees off of north. So I go from A to point B. I'm going to end right here at point B. The distance 80 kilometers from there to point C on a bearing of 123. So I'm going to draw another north-south line, and I'm going to point C over here, and it's 123 degrees. So I rotate off of due north 123 degrees. So I come down 90 is right about there, and then 123 is there. So this is 123 degrees off of north, and this takes me to point C. I haven't drawn quite to scale, but I'm a little more to scale than usual. It's AC right there. So Porpor flies from A to B on a bearing of 67 degrees for a distance of 80 kilometers. From there to point C on a bearing of 123 degrees. Find angle ABC. So the first thing I'm asked to find is this red angle here, ABC. So this red angle here is what I'm looking for. Let me go back a step to parallel lines. So if I have parallel lines cut by a transversal, I know that these angles are corresponding angles and they are congruent. These angles are alternate interior angles and they're congruent. These angles are alternate exterior angles and they're congruent. So all four of those angles are congruent, and these are the supplement of those. So if this is 67 degrees and this line are parallel, then this little interior angle here is 67 degrees. So I have that. And then if this is a straight line there, right, so this is 180 degrees, I do 180 minus 123, and I get 57 degrees. So that little angle there is 57 degrees. So that red angle is the sum of 67 and 57, 124. So this red angle is 124 degrees. Here's my picture in the book. So they're telling me this is 120 kilometers. So now I have side angle side angle side of this large triangle. So I'm going to use the law of cosines. So I'm going to take the side opposite the given angle. B squared is equal to one leg squared plus the other leg squared minus 2 times one leg, the other leg, cosine of the angle opposite the side, so cosine of 124 degrees. So then I'll use my graphing calculator. Before I start on this, I always go to mode, make sure I'm in degree mode. So I'm in degree mode. If I wasn't, I go down to it, highlight it, hit enter, and then quit. Then what I'm doing here is I'm just evaluating all of this. I'm actually going to work from right to left. So I'm going to take cosine of 124 equals times 120 equals times 80 equals times -2 equals. So that's 10,736. And I multiply by a -2, so this is all positive, and I'm going to add 120 squared, and I'm going to add 80 squared, and that means b squared is equal to that number, 31,536. Solving for b, I take square root of both sides, so square root of that answer is 177.6. So this is 177.6. So let's look back at the problem here. Part A, find angle ABC. That's 124 degrees. Part B, calculate the distance for Porpor to fly from C to A. From C to A is 177.6 kilometers. And then part C, right here, part C, find the bearing that Porpor must fly to return to A from C. So what I need to do here is draw a vertical line. And what I'm looking for is I start at point C and I go to point A. So I'm looking for this angle here because it's a bearing off of due north. So I'm looking for that angle there. Let's see, this is perfectly vertical. This is perfectly vertical. So I have these vertical lines cut by this transversal. So if this is 57, this is 57 degrees. If I could find the measure of the angle here, that black angle, then I could subtract 57 and that black angle from 360, and that'll give me my bearing off of north. So I want to find that black angle. So now I'm going to use the law of sines. I'm going to take the sine of 124 degrees over the side opposite it, 177.6 kilometers, is equal to the sine of this black angle, we'll call it theta, sine of theta, over the side opposite it, 80 kilometers. Then now I have one ratio equal to another proportion. I'm going to cross multiply, again in degree mode. I'm going to go sine of 124 times 80. So I'm taking this times that equals that times that. So sine of 124 equals times 80 equals 66.3. 66.3 equals that times that. So 177.6 sine of theta. Still solving for theta, I divide both sides by 177.6, and I get sine of theta equals 0.37. Solving for theta, I take the arc sine of both sides, so second sine of my answer, and I get 22 degrees. So this is 22 degrees. This is 57 degrees. So together, that angle right there is 79 degrees. So the full angle there is 79. So even though I use the full page, it's still getting a little crowded. So I want to figure out this angle. So that is going to be 360 degrees minus 79 degrees, which gives me 281 degrees. So part C is saying find the bearing from point to fly to return to A from C. Well, I fly 177.6 kilometers at an angle of a bearing of 281 degrees. So just a couple quick review things. So these are the bearing problems. A couple things I'd really remember or put in your notes is parallel lines, whether they're vertical or horizontal, are denoted with double arrows. Cross by a transversal. This angle is congruent to this angle, congruent to that angle, congruent to that. So those four angles are congruent. This black angle here is the supplement of that red angle. So if that's 20, that's 160. And then all these black angles are congruent, so there's only two. So you could do a lot with just knowing those parallel lines. Second thing you need to have in your notes is the law of cosines. Law of cosines is a squared equals b squared plus c squared minus 2 times b c cosine of the angle opposite that side. So cosine of A. 3 ways to write that. One of the keys to this equation is that you keep track that capital is always measure of an angle, lowercase length of a side opposite that angle. Angle B, this would be side B, angle C, side C. You could use the law of cosines if I have a side, an angle, and a side. So if I had C, A, and angle B, or if I do that, I could use that to find side B, or I could use it for side, side, side. If I have side A, side B, and side C, I could find angle B or angle A, angle C. Okay. Then we have the law of sines. Law of sines is sine of any angle over the side opposite it is equal to sine of any other angle over the side opposite it. So again, 4 variables, A, C, both angles, side A, C, I have to have 3 of those. So I got to be careful not to use side-side angle, because that's not a way to prove triangles congruent. So I could use the law of sines if I know all of the angles, and say angle, side, angle, triangle if I'm using angles here and one side to find another side. Or if one of the angles I'm using is obtuse, it'll give me a definitive answer. Obtuse greater than 90. A lot of times, even though it seems like I could set it up, if I'm using a side, and an angle, it won't give me a definitive case. So in that case, I'd have to use the law of cosines. And then lastly, area of a triangle is equal to 1/2, one leg, the other leg, sine of the angle between them. So 1/2 A, B, sine of C. So those are the notes on all these bearing problems. Anything to do with the bearing is always clockwise off of north. So you go clockwise off of north. So this would be your first, second, third, fourth quadrant. These would be values between 0 and 90, 90 and 180, 180 and 270, and 270 to 360. That is different than the way we've been doing it all along. These are bearing problems, common in navigation. The way we've been doing right triangle trig is everything is not defined on the north, south, east, west plane, but rather the XY plane. And if you're doing trig in XY, you're counterclockwise off of X, but a bearing is clockwise off of north.